We now sketch the graph of the function defined by this greatest integer function y equals the floor of 2x minus 1 for values of x greater than equal to negative 2 and less than equal to 2. And please take note of the correction in the values of x. Earlier I wrote greater than equal to negative 1, but these are really the values of x. We will sketch the graph of this function for these values of x greater than equal to negative 2, less than equal to 2. Please take note of this correction. Now we sketch the graph of this greatest integer function for these values of x. Now we consider each interval an interval of size 1 unit from negative 2 to positive 2, and we start from the left endpoint negative 2. A 1 unit interval is from negative 2 to negative 1, and another 1 unit interval is from negative 1 to 0. And from 0 to 1, that's a 1 unit interval. 1 to 2, that's another 1 unit interval. When the technique in sketching the graph of greatest integer function is to find the values of y over an interval of 1 unit. That is, you find the values of y over an interval of 1 unit that is between 2 integers. So we consider now the first 1 unit interval from negative 2 to negative 1. When x is negative 2, when x is negative 2, the value of y equals the floor of 2x minus 1, where x is negative 2. 2 times negative 2 minus 1 equals negative 5. When x is negative 1, the value of y equals 2 times negative 1 minus 1. We are actually evaluating the endpoints of this interval to see if we will generate values of y over a 1 unit interval also. Now, when x is negative 1, x equals negative 1, the value of y is the floor of 2x minus 1, where x is negative 1. 2 times negative 1 minus 1 equals 2 times negative 1 is negative 2, minus 1 is negative 3. When x is negative 1, our y is the floor of negative 3. Between negative 2 and negative 1, that's a 1 unit interval. But the values of y for real numbers between these intervals, between the real numbers negative 2 and negative 1, is not a 1 unit interval. The values of y for values of x between negative 2 and negative 1 are between the floor of negative 5 and the floor of negative 3. And that's not a 1 unit interval because there is an integer between negative 5 and negative 3. And that integer is negative 4. And that value of y, the floor of negative 4, corresponds to the value of x. Between negative 5 and negative 3, you have negative 4. For y equals the floor of negative 4, the value of x is the real number between negative 2 and negative 1. And that real number is negative 3 over 2. Negative 2 plus negative 1 is negative 3 divided by 2, negative 3 halves. when x is negative 3 over 2, multiply 2 by when x is negative 3 over 2, you get 2 times negative 3 over 2 is negative 3 minus 1. You get y is equal to the floor of negative 4. Thus, we have a 1 unit interval between negative 5 and negative 4. And those values of y between the floor of negative 5 and the floor of negative 4 are for the values of real numbers. For the values of x, the real numbers between negative 2 and negative 3 halves. Thus, we will consider intervals from negative 2 to negative 3 halves, from negative 3 halves to negative 1. From negative 1 to negative 1 half. We divide each 1 unit interval into 2 to generate values of y within a 1 unit interval from negative 5 to negative 4, from negative 4 to negative 3. And so we start with the interval negative 2 to negative 3 halves. Again, if x is negative 2, the value of y is the floor of negative 5. And the floor of negative 5 is the greatest integer that is less than or equal to negative 5. And that integer is negative 5. And we indicate that by a point or shaded circle in our graph. When x is negative 2, the value of y is negative 5. This is the point that corresponds to x equals negative 2 and y is negative 5. We now consider the values of x that are greater than negative 2 but less than negative 3 over 2. And if you take a value of x that is very close to negative 2 but greater than negative 2, say negative 1.99, if x is negative 1.99 and you substitute the value of x here, then the value of y is the floor of 2 times negative 1.99 minus 1. Y is equal to the value of the greatest integer function 2 times negative 1.99 minus 1. And if you will use your calculator, you should get negative 4.98. And the floor of negative 4.98 is the largest integer that is less than negative 4.98. And that integer is negative 5. Hence, if x equals negative 1.99, the value of y is negative 5. If x is negative 1.99, the value of y is negative 5. Now we take a value of x that is very close to negative 1.5 or negative 3 over 2, but less than negative 3 over 2, or less than negative 1.5. I will take x equals negative 1.51. If x equals negative 1.51, you substitute the value of x here, then the value of y is equal to 2 times negative 1.51 minus 1, or y is equal to the floor of negative 4.02. And the floor of negative 4.02 is the largest integer that is less than negative 4.02, and that integer is negative 5. If you take any integer less than, greater than negative 2, but less than negative 3 over 2, the value of y is always negative 5. And the graph would be a horizontal line from negative 2 up to negative 3 over 2, but not including negative 3 over 2. Because if x is negative 3 over 2, here, if x is negative 3 over 2, you substitute x in this greatest integer function. The value of y is negative 4. 2 times x, x is negative 3 over 2, you get minus 3 minus 1, you get negative 4. And the floor of negative 4 is the greatest integer less than or equal to negative 4, and that integer is negative 4. Hence, for values of x greater than negative 2, but less than negative 3 over 2, such as negative 1.99 and negative 1.51, the value of y is negative 5. But not at x equals negative 3 over 2. At x equals negative 3 over 2, the value of y is negative 4. So to indicate that if x is negative 3 over 2, the value of y is not 5, we draw an open circle at the point negative 3 over 2 and negative 5. But the value of y for values of x greater than negative 2 but less than negative 3 over 2 is negative 5. And the graph is a horizontal line. Now we consider the interval from negative 3 over 2 to negative 1 is starting at negative 3 over 2. And we have shown that if x is negative 3 over 2, the value of y is negative 4. So we plot this point negative 3 over 2 and negative 4. X is negative 3 over 2 and y is negative 4. That is the graph of when x is negative 3 over 2 and y is negative 4, a point. Now we consider the real numbers that are greater than negative 3 over 2 or greater than negative 1.5 but less than negative 1. If we take a number very close to negative 3 over 2, say negative 1.49, if x is negative 1.49, you multiply it by 2 and subtract 1, you should get negative 3.98. If x is negative 1.49, you substitute in this greatest integer function, and y is the floor of negative 3.98. And the floor of negative 3.98 is the largest integer that is less than negative 3.98. And that integer is negative 4. Hence, when x is negative 1.49, very close to negative 1.5, the value of y is negative 4. Now, I will take a real number very close to negative 1, but not equal to negative 1. Very close to negative 1, but less than negative 1, say negative 1.01. Negative 1.01 is less than negative 1. If x is negative 1.01, substitute in the greatest integer function 2 times x negative 1.01 minus 1, and if you use your calculator, you should get negative 3.02. Again, when x is negative 1.01, y is the floor of negative 3.02. And the floor of negative 3.02 is the greatest integer less than negative 3.02. And that integer is also negative 4. And if you want to test all the real numbers that are greater than negative 3 over 2 but less than negative 1, the value of y is negative 4. And that is represented by a horizontal line from this point up to negative 1. But at negative 1, we draw an open circle, because if x is equal to negative 1, you get 2 times negative 1 is negative 2. Minus 1 is negative 3. So y is the floor of negative 3. And the floor of negative 3 is the greatest integer less than or equal to negative 3. And that integer is negative 3 when x is negative 1, the y is negative 3, and not negative 4. So the horizontal line goes from this point up to negative 1, but at negative 1 we put an open circle. This graph indicates that for values of x equal to negative 3 over 2 and greater than negative 3 over 2, the value of y is always negative 4. But when x equals negative 1, the value of y is not negative 4. So we draw an open circle at this point. But when x equals negative 1, the value of y is the floor of negative 3, which is negative 3. When x equals negative 1, y is negative 3. And we plot a point. We plot that point, negative 1 and negative 3. Now we take real numbers greater than negative 1 but less than negative 1 half or negative 0.5. I would take one real number that is very close to negative 1 but not equal to negative 1. Say negative 0.99. Negative 0.99 is greater than negative 1. If x equals negative 0.99, substitute the value of x here. 2 times negative 0.99 minus 1. Using your calculator, you should get negative 2.98. So if x is equal to negative 0.99, the value of y is the floor. The greatest integer that is less than negative 2.98, and that integer is negative 3. When x is negative 0.99, negative 0.99 is in this interval. When x is negative 0.99, the value of y is negative 3. Now I will take a real number that is very close to negative 1 half or negative 0.5 but less than negative 0.5. I will take x equals negative 0.501. Negative 0.501 is in this interval. It is less than negative 0.5 but very close to negative 0.5. When x equals negative 0.501, substitute in the greatest integer function. 2 times negative 0.501 minus 1. Using your calculator, you should get negative 2.002. When x equals negative 0.501, the value of y is the greatest integer that is less than negative 2.002. And that integer is negative 3. So when when the values of x are in this interval, such as negative 0.99 and negative 0.501, the value of y is negative 3. X is negative 0.99, the value of y is 3. X is negative 0.501, the value of y is 3. But when x is negative 1 half, the value of y is not negative 3. If x is negative 1 half, x equals negative 1 half, you substitute negative 1 half for x. 2 times negative 1 half is negative 1. minus 1 is negative 2. When x equals negative 1 half, the value of y is the greatest integer that is less than equal to negative 2, and that integer is negative 2, not negative 3. Hence, for the real numbers that are greater than negative 1 and less than negative 1 half, but not equal to negative 1 half, the value of y is always 3. This part of the graph means that for any value of x in the interval from negative 1 to negative 1 half, excluding negative 1 half, the value of y is always negative 3. But when x equals negative 1 half, the value of y is not negative 3. But if x equals negative 1 half, the value of y is negative 2. That is why at this point we draw an open circle to indicate that this is not the graph for the value of x equals negative 1 half. Because if x equals negative 1 half, the value of y is negative 2. So we plot this point negative 1 half and negative 2. X is negative 1 half and the value of y is negative 2. Now we consider the real numbers that are greater than negative 1 half but less than 0. Negative 1 half is negative 0.5. Suppose I take a real number very close to negative 0.5 but greater than negative 0.5. I will take x equals negative 0.49. Negative 0.49 is in this interval. It is greater than negative 0.5. If x equals negative 0.49, substitute here in the greatest integer function, 2 times negative 0.49 minus 1. Using your calculator, you should get negative 1.98. Hence, when x equals negative 0.49, the value of y is the greatest integer that is less than negative 1.98. And the largest integer less than negative 1.98 is negative 2. When x is negative 0.49, the value of y is negative 2. Now, I will take a real number very close to 0 but less than 0. I will take negative 0.01. If x equals negative 0.01, substitute here in the greatest integer function, 2 times negative 0.01 minus 1. And using your calculator, you should try it. You should get negative 1.02. Thus, when x equals negative 0.01, the value of y is the greatest integer that is less than negative 1.02. And that integer is negative 2. When x is equal to negative 0.01, the value of y is negative 2. But when x is exactly equal to 0, when x is exactly equal to 0, substitute here, you get 2 times 0 is 0 minus 1. You get y equals the floor of negative 1. When x equals 0, y is the greatest integer less than equal to negative 1, and that integer is negative 1. But for the real numbers in the interval from negative 1 half up to 0, excluding 0, the value of y is always negative 2. As we have shown, we let x equals negative 0.49 and x equals negative 0.01 that are both in this interval from negative 1 half to 0, and the corresponding value of y is negative 2. So for any x, real numbers in this interval, the value of y is always negative 2. And we represent that by this horizontal line. But as I said, when x equals 0, the value is not negative 2. The value of y is not negative 2 when x equals 0. When x equals 0, the value of y is negative 1. And we indicate that with an open circle at this point because when x is 0, the value of y is not negative 2. But when x equals 0, the value of y equals negative 1. So we plot this point 0, negative 1. X is 0, y is negative 1. We plot a point at this point. X equals 0, y is negative 1. Next, we complete the graph from 0 to positive 2. Now, consider the interval from 0 to 1 half or 0.5. And we take real numbers that are greater than 0 but less than 1 half. I would take again a real number very close to 0, say 0.01. 0.01 is in this interval. When x is 0.01, substitute in the greatest integer function and use your calculator. 2 multiplied by x, 0.01 minus 1, and you should get negative 0.98. So when x equals 0.01, the value of y is the greatest integer less than negative 0.98, and that integer is negative 1. When x is 0.01, the value of y is negative 1. Now I will take a value of x close to 1 half or 0.5. I will take x equals 0.49. When x equals 0.49, substitute in the greatest integer function. 2 multiplied by 0.49 minus 1, and using your calculator, you should get negative 0.02. That is, when x equals 0.49, the value of y is the greatest integer less than negative 0.02, and that integer is negative 1. When x equals 0.49, the value of y is negative 1. Actually, if you take any real number from 0 to 1 half, excluding 1 half, you will get the value of y equals negative 1. And we represent that by horizontal line from x is 0, y is negative 1, up to a real number very, very close to 1 half, but not equal to 1 half. Because when x equals 1 half, the value of y is equal to 2 multiplied by 1 half is 1, minus 1 is 0. When x equals 1 half, the value of y is the floor of 0. And the greatest integer that is less than or equal to 0 is 0. So when x is 1 half, the value of y is not negative 1, and we indicate that by open circle. Now we consider the interval from 1 half to 1. When x is 1 half, we have shown that y equals 0. So we plot the point x is 1 half and y is 0. X is 1 half and y is 0. Now we consider real numbers that are greater than 1 half or 0.5 but less than 1. I will take a number very close to 1 half but greater than 1 half. I let x equals 0.501. 0.501 is greater than 0.5 or 1 half. So it is in this interval. And when x is 0.501, substitute in the greatest integer function 2 times 0.501, minus 1. Using your calculator, you should get 0.002. Thus, when x is 0.501, the value of y is the greatest integer, less than or equal to 0.002, and that integer is 0. When x is 0.501, the value of y is 0. Now, I will take a real number very close to 1, but less than 1. I will take x equals 0.99. Substitute in the function 2 times 0.99. 2 times x is 0.99 minus 1. And by using calculator, you should get 0.98. Hence, when x is 0.99, the value of y is the floor of 0.98. That is the greatest integer that is less than 0.98, and that integer is 0. When x is 0.99, it is in this interval, the value of y is 0. But if x is 1, the value of y is the floor of 1, which is 1. If x is 1, you get 2 times 1 is 2 minus 1 is 1. When x is 1, the value of y is 1. So but for the real numbers between 1/2, including 1/2, and 1, excluding 1, the value of y is 0. And we represent that by horizontal line from this point up to 1. And at 1, we draw an open circle. Because at x equals 1, the value of y is not 0, but 1. When x is 1, the value of y is 1, and we plot that point. X is 1, the value of y is 1. Next, we consider the interval from 1 to 3 over 2. That is, we consider real numbers that are greater than 1, but less than 3/2 or less than 1.5. I will take a real number greater than 1, but very close to 1. I will take x equals 1.01. If x is 1.01, substitute in the given function 2 times 1.01 minus 1, and using calculator, you should get 1.02. When x is 1.01, the value of y is the greatest integer less than 1.02, and that integer is 1. When x is 1.01, it is in this interval, it's greater than 1. The value of y is 1. Now I will take a real number very close to 1.5 but not equal to 1.5. I would let x equals 1.49. 1.49 is in this interval, very close to 1.5. If x is 1.49, substitute in the given function 2 times 1.49 minus 1, and you should get 1.98 using calculator. When x is 1.49, the value of y is the floor of 1.98, or the greatest integer less than 1.98, and that integer is 1. When x is 1.49, the value of y is 1. Hence, for real numbers, you can check, you can assign any real number between 1 and 3 over 2, excluding 3 over 2, and you will get y equals 1. And we represent that by horizontal line from this point up to this point, but excluding this point, because when x is 3 over 2, the value of y is not 1, but 2. The open circle here, that the point 3 over 2, 1 is not included in this part of the graph, because when x is 3 over 2, Substitute here. 2 times 3 over 2 is 3 minus 1 is 2. When x is 3 over 2, the value of the greatest integer function is 2. When x is 3 over 2, the value of y is 2. And we represent that by a point. Now we consider the real numbers from 3 over 2 to 2. Those real numbers that are greater than 3 over 2 are 1.5 but less than 2. Again, I will take a real number greater than 1.5 but very close to 1.5. I let x equals 1.501. 1.501 is in this interval. It is greater than 1.5. And when x is 1.501, substitute in the greatest integer function 2 times 1.501 minus 1, and you should get 2.002 by using calculator. Hence, when x is 1.501, the value of y is the floor of 2.002, or the greatest integer that is less than 2.002, and the greatest integer is 2. When x is 1.501, the value of y is 2. X is 1.501, the value of y is 2. Next, I will assign a value of x greater than 3 over 2, but less than 2 and very close to 2. I let x equals 1.99. 1.99 is very close to 2, but less than 2. When x is 1.99, substitute in the given greatest integer function 2 times 1.99 minus 1, and using your calculator, you should get 2.98. Hence, when x equals 1.99, the value of y is the greatest integer less than 2.98, and that greatest integer is 2. When x is 1.99, the value of y is 2. In the graph, when x is 1.99, the value of y is 2. Thus, for real numbers from 3 over 2 to 2, we draw a horizontal line. Because for these real numbers, between 3 over 2 and 2, excluding 2, the value of y is always 2. But at x equals 2, we draw an open circle. Because when x equals 2, the value of y is not 2. When x equals 2, here when x equals 2, substitute in the given function, 2 times 2 is 4, minus 1 is 3. Hence, when x is 2, the value of y is the floor of 3, or the greatest integer that is less than or equal to 3, and that integer is 3. When x is 2, the value of y is 3. So we plot this point 2, 3. And this is the complete graph of the greatest integer function y equals the floor of 2x minus 1, where x is a real number in the closed interval from negative 2 to positive 2. For your practice and assignment, please try the following exercises. Number 1, find the value of each of the following. Letter A, you have the ceiling of E. E is an irrational number and it's approximately 2.7 something. B, you have the floor of negative E. C, the ceiling of negative E. D, the floor of positive E. And letter E, you want this is actually another notation for the floor of a real number, and here we have the irrational number pi over 2. Letter F, this is another notation, the same notation for the floor of 72. Or in letter E, you want the greatest integer that is less than equal to pi over 2. In letter F, you want the greatest integer less than equal to 72, and that's the floor of 72. In letter G, you want the floor of square root of 5. And H, you want the value of the ceiling of square root of 5 over 2. And for number 2, sketch the graph of this greatest integer function. Y is equal to the negative of the floor of the real number x, where the real number x is between the closed interval from 2 to 4. And that completes our lesson for today on floor and ceiling. But we will continue this lesson in the next lesson. And if you have question about the lesson today, you ask your question in the comments below. But don't forget to subscribe to my YouTube channel, Art Calison, the channel of learning and leisure. Or you may ask your friends, your classmates, your neighbors, and relatives to subscribe to my YouTube channel, Art Calison, so they may learn as well. Thank you for joining me in my class today in number 2.